don't know what who's picky about. Great. All right, so we're going to do an exam. Exam moved to next Monday, and that's Thanksgiving week. Okay, and let me know if you need to take the exam on Friday. Okay, let's see. Help sessions, I'm available Monday, Wednesday, 1 to 5 p.m. Help by appointment, but really just let me know in class. And really, I don't know, I've had many days I've even been out of here by 5, so you could stop by and there'd be decent odds I'd be there. Okay, and then I'll do a help session. Well, yeah, I'll do a help session on Thursday. It's extra help. Since we don't have a quiz, I don't know if people will show up, but help session Thursday, 8:30, whoops, at 7:30. Okay, on Google Meet. Questions on things we've got going? Okay, great. So let's go ahead and let's just start reviewing stuff. So a couple things. So one thing I want to review, what we'll do is we'll maybe work some problems, and I want to take problems out of the back of your book when we do these. But let's go ahead and first talk generally. The thing that people had the most difficulty on the quiz was the dimensional analysis stoichiometry problem. All right, so let's talk about what we're doing with stoichiometry in here. So I've talked about this before. This is like the moles to moles highway, right? So if we're trying to calculate some reaction from A to B, right, let's actually make it like our reactions. But our reactions have a bunch of things, right? Let's make it super complicated. Let's say we've got A to B to C goes to D to E to F. Okay, we've got some complicated thing like that, and what we're trying to do is these calculations are always from one thing to another thing. Okay, they're never to one thing to two things. You'd have a calculation one thing to another thing, and then if you needed to figure out something else, if I need to figure out E and F, I would do whatever to E and then whatever to F. They're two separate calculations. All right, and then our calculations, so let's say one of those calculations we're trying to go, let's actually go backwards. You can go any direction here, right? Okay, let's say we're going to, well, I'm just going to say you can go any direction, but we've been doing limiting reagent problems, and almost always you're going to be going this way. So I think to make it less confusing for my example, I'm going to go B to E. Okay, so we're going to use our moles highway. So we go moles of B goes to moles of E. All of these things that we do here, we're going to have a conversion factor to get from one to the other. And I could draw these as arrows going both ways because you can convert one way or the other. What is our conversion factor from going from moles of B to moles of E? It's the whole number ratios from the balanced equation, right? Always. And I say whole number ratios because that's what, when you balance the equation, you're supposed to do in chemistry, right? But actually, if they were the right ratios and they weren't whole numbers, it still would work. All right, you wouldn't actually need it to be a whole number ratio. And then there are all sorts of ways we can get on the highway, right? We can start with grams of B. Okay, we could start with volume of B. We could start with molecules of B. We started with anything else in here? Okay, I haven't seen your problems and I won't do it to you, but we could start with a volume, a pressure, and a temperature of V. And with PV energy, you can solve for moles, right? Okay, you can get to moles from there. Since I don't see your problems, I'm not going to do that to you. But grams of V to moles of V, what's that? How do we get, what's our conversion factor there? It's the molecular mass of V, right? Volume of V, so this is a solution volume, to moles of V. It's molarity, right? Our molarity is moles per liter, so if I have volume, okay, and then molecules of V, what's that? Avogadro's number. Questions on that general path? So if you've been having problems with these, I know I've done this before, remember this, okay? Remember this general path and then what conversion factors you need. You could even, for partial credit on your quizzes and tests, write out what the path is supposed to be, even if you don't know how to get the conversion factors. All right, that would be worth something. Okay, out the other end here, we go from moles of E to maybe grams of E. Okay, or maybe now we go to volume of E. Or maybe here we're going to go to molecules of E. And we're going to use the same conversion factors there. It's going to be a little bit of a mess. Okay? But if we're going from moles to grams, we use molecular mass. If we're going from moles to volume, we're going to use molarity. If we're going from moles to molecules, we're going to use Avogadro's number again. Okay? Questions on the path? I think that's all the types of problems we have, right? Keeping in mind, sometimes you might start here, right? Sometimes you might end here as well, okay? You don't have to go all the way down the highway. You can stop in the middle of the highway. I don't recommend it in real life. Okay, so let's go ahead and try a problem. So when we do our limiting reagent problems, what we're going to do is you're going to be given, in general, limiting reagent problems, you are given the amounts of two reactants. Let's say two or more reactants. All right, and what you need to do is figure out how much product each makes. All right, the smallest amount of product tells you which reagent. The reagent that makes the smallest amount of product is the one that's a limiting reagent. Okay, and let's do this. And that's how much product is made. And going into the next topic I'm going to talk about here, that's our theoretical yield. Okay, so in other words, if everything that could react, let's say it's two reagents, if one of them is limiting, one is not, they both react as much as they can. One is left over because the other one was limiting. Okay, if they react as much as possible, that's our theoretical yield. I think I didn't want to say anything else about that. And so generally, if a problem is asking you how much of some product is being made, then when I figure which product I'm going to figure out makes the small, if I'm picking the product that's the smallest amount made, I'm going to pick the one it's asking for, just because it's easier. You wouldn't need to. You could figure out the limiting reagent, and then you could do that problem again. And at least so far, and I'm going to keep trying to aim to do that. Most people had lots of time on the tests, so you could do that. So that's the limiting reagent. So percent yield. For a percent yield problem, you're going to determine how much stuff was made based on the limiting reagent. Determine how much product could be made it's a limiting reagent problem, and that's going to be your theoretical yield. Okay, and then you're going to use the percent yield equation. Okay. For this problem, you will be given an actual yield to determine percent yield. You can't calculate an actual yield. I mean, you could, so-and-so weighed this much on the balance beforehand and this much on the balance afterwards, right? Could be that. We haven't done that. That's something they'd have you do in lab. Wouldn't give that to you because that would be new. So you will be given the actual yield. Okay, and I didn't see many people having problems with where I saw the equation. Then remember the percent yield equation is going to be equal to actual yield over theoretical yield. Times 100%. Okay, don't forget the 100%. So another thing about your quizzes, so the quizzes that I just handed back, please try to show as much work as possible. The more work you show, the more partial credit I can get. Okay, so I was looking through people's work and trying to figure out where I could give people points if they didn't have the correct answer. And the more work I see, the more possibilities I have to give you credit. Any questions so far? Okay. Well, let's go and take a problem from your book. So if we go to achieve, we change their front page. Let's see, we are in, let's do stoichiometry. Stoichiometry is one of the toughest things in this class. It doesn't go away, unfortunately. Let's start with molarity and solution stoichiometry here. And I hope you've noticed, I've tried to make it pretty obvious that for your quizzes, and I might do this on the exam as well, that I'm taking problems, I'm taking the odd number of problems from the back of the book. Those are the ones you have the answers for. So if you use those for practice, you might happen to get one on the test or a quiz that is the same as something you've already practiced. We, however, for in here, we're going to grab, what is this, the limiting reagent? There we go. Let's get to molarity. We are going to work, well, let's just start with this one. Let's start with one of these. Start with A. Can you guys all see that from where you are? Yeah? No? Okay. Close this down. Make it bigger. There we go. Oops, we lost it. There. Start with A. If you get A, do B. Okay? This is not a full stoichiometry problem. It's just calculating molarity. Notice that you've got kilograms, so you're going to have to convert to grams, right? And 1,000 grams is equal to 1 kilogram. All right. I will give you any constants on a quiz or test. I noticed that on the back page, that page I gave you didn't actually have your metric conversions. Turns out you don't remember your metric conversion, and I didn't put it on your test or something. You can ask me. Just ask straight out on a quiz or test. I need this conversion back. Okay? If something like that happens. And if you're not sure how to start, you have to come over and ask, or just call me over. going to give folks maybe 2 more minutes. Anybody done with the second one? Almost done with the second one? Okay. Let me know when you're done with the second one. Yep. Yeah, formulate for sodium chloride. Yeah. I'm going to wait till somebody has the answer for the second one so I can give you the answer. But, yeah, you're done. All right, so let's flip over to these notes over here. So what did we have? You guys have this because it's on your paper. We had, was it 2.3 kilograms? We had 2.3 kilograms of, I should actually snapshot that and bring it over here. I'll do that next time. 2.3 kilograms of sugar. Sugar is C, was it 11? No, it's 12. C12, it's H22, was that it? H22O11, yeah? Okay, and the molecular mass of that, I was saying 342, was that it? 342? Molecular mass of sugar was 342. Were you giving me decimal points? What were the decimal points? 0.88 grams per mole. All right, and then what else did we have? 55 liters, right, was our volume, and then it was calculate molarity. Okay, so we had that, and so the first part of this problem was to take our 2.3 kilograms and we were going to turn that into grams, right? So 1 kilogram was equal to 1,000 grams. All right, and then so kilograms cancels with kilograms, and then we have, if we have 342 grams, we have 1 mole. There's just one thing here, so I'm not going to worry about talking about what the substance is. Have I made an error here? Nope. Okay, just checking. And so then if I have, so that's going to get me into moles of sugar, right? And so I want moles over liters, so I could plop out the moles here, and that's what I'll do. And then my equation for molarity is equal to moles divided by liters. So I'm going to take this thing and put it there, and that's going to be divided by 55. So 55 liters. If I multiply across the top and divide by the bottom, what do I get? 6.7. So 6.7, I have 2 sig figs over in kilograms, so we're going to go with moles here. And so then 6.7 divided by 55 is equal to 0.12, which is what I was seeing on a bunch of people's papers. And don't forget your molar, 6.12 molar, all right? And a good thing to do on your quizzes and tests as well is to clearly indicate which answer is the answer. So if there's stuff all over the place and the right answer is in there somewhere along with a bunch of other stuff and I'm not sure, that can be problematic. I don't remember that with the last quiz, okay? But as long as I'm in hints on doing your work for quizzes. So this was A, right? What was that? It was 70A? You guys remember? Let's take a look at that real quick. I hope it, okay, good. 70, yep, 70A. This is from your book. So 70A. And then the answer for 70B, what'd you get, Tyler?
I realized I did wrong.
Okay. Jack, what'd you get?
I didn't get to finish it.
You need to finish it? Okay. Well, we'll do 70B real quick, okay? It has some number of milligrams, unless somebody else has it. Somebody else want to offer? Okay. So let's do 70B. We'll do it more together, though. So 70B, here, I'm going to actually pull these over now. All right. So 70B, we've got a solution with a certain number of milliliters of sodium fluoride, and then a certain number of milligrams of, certain number of milligrams of sodium fluoride. Oh, so this is milligrams per milliliter, and it wants us to go to molarity. Okay, great. But lots of conversions here, right? We've got two things we need to convert. So first of all, our molarity, remember, our molarity is moles per liter, right? So if it's moles per liter, what do I have to do with milliliters? Convert it to liters, right? So let's go ahead and do that. I've got 8.92 milliliters. If I have, how do I do my conversion here? How many milliliters in a liter? 1,000. Okay. So what goes on the bottom here? 1,000 milliliters equals 1 liter. Okay, and so we're going to end up with 0.00892 liters. All right, milliliters cancel to the milliliters. All right, so we've got we've got that in liters. Great, we're all ready with that. Now we need to get the other one into moles. First thing is we're in milligrams, and we're going to need to be in what to go to moles? Grams, right? All right, so you've got 1.27 milligrams. I'm not going to write down that it's sodium fluoride because we don't have two compounds here. How many milligrams in a gram? 1,000. So once again, I was going to say this is tricky, but it's not. 1,000 on the bottom, right? So it cancels, equals 1 gram, milligrams to grams. And then we can go on once we have our molecular mass, right? I'm not even going to bother finishing this just yet. The next thing I need is the molecular mass so I can get to moles. The molecular mass of sodium fluoride, do you have that?
I said 41.99.
41.99?
I just rounded up to 42.
Okay. Either is fine. Okay. One of those will be correct, but either is fine. They're both close enough. So one of those will be correct, not in terms of grading. Because actually when I do these, everybody has a slightly different periodic table. I don't know if you noticed. I just grab whatever's underneath here and I hand it out. And those numbers change depending on which periodic table you have based on how old that periodic table is, really. It isn't that the actual fundamental numbers change, but they get more accurate all the time. But so we've got 41.99 grams equals 1 mole of sodium fluoride. What goes on the bottom here? The grams, and 41.99 goes with the grams, right? It's next to the grams, and the thing that's divided is 1 mole. And so we can multiply across the top and divide by the bottom. You guys already do that?
I got 3.02 times 10 to the negative 5.
3.02 times 10 to the negative 5. Let me look at it. Yeah, okay. Seems about right. Now, I didn't do it to 3 significant figures in my head. But so what I'm going to do then is I'm going to go 3.02 times 10 to the negative 5. Remember, up here, molarity is equal to moles divided by liters. So we're going to divide that many moles divided by 0.00892 liters, and that's going to be equal to something that's less than 1, but not maybe -2? 3.02. You guys aren't jumping in quick enough, so I'll
3.39 times 10 to the
3 minus 3. 3.3. We have three significant figures starting over. 3.39 times 10 to the minus 3 molar. Don't forget your units. That make sense? Questions on this molarity stuff? Yes, Madeline. Right, that's a good question. So if you write it like this in standard notation rather than scientific notation, it's perfectly fine. Okay, and your calculator might be set for one or the other. The only place where I would have an issue with this is if we had, let's say we had three significant figures here, and there were a lot of these, your calculator is going to read out a bunch of zeros in one digit, and you're going to lose the rest. Does that make sense? So there would be a problem, and our issues with significant figures. I just want you to be close, but if you make something that is not one into one, that's a problem because you're losing a lot of stuff. So you can imagine if let's say it's 0.000000001 in your calculator. Well, that's anything between 1, 5, the zeros in a 1, 5, and the zeros in a 5. Does that make sense? So in terms of that, there's a huge error when you do that sort of rounding. So that's the only place where that'd be an issue. Otherwise, it doesn't matter. Okay. Other questions? All right, let's look at another one of these. Let's actually do one that is actually full solution stoichiometry. Hopefully we can find it okay. Carbonic acid. Okay, so this is not a percent yield, but it is a good, I wish that stuff wasn't there. I'm gonna, what were we on? Was it 90? Was it just 90? 70. No, it'd be just, yeah, okay. Oh, we're not doing that one. I've done that one. I feel like I've done one in these threads. All right, let's do this one. Okay. So zinc reacts to hydrochloric acid according to this equation. If this many liters of that molar HCl is added to an excess of zinc, not a limiting reagent problem. Okay. How many moles of zinc chloride are produced? And then it actually asks you to calculate molarity. That was 88, was it? Yes. Just want to have all of 88 on the screen at the same time. Is that so much to ask? There. Okay. Go ahead and get started. I'm going to copy and paste that over to my notes. And focus on the first part first. Sorry about that. I'll let people get going and I'll paste that over. If you are not comfortable with this concept of excess, call me over. I'll explain it.
So here we're going to be writing moles, right? So what is it? Moles of hydrochloric acid, which is moles of zinc. So you can get moles of hydrochloric acid, given the molarity, given the liters. So you can write out the molarity. So now we want to solve for moles. Given the molarity, given the liters. So let's say moles. So go ahead and multiply both sides with just with equal economic numbers and multiply both sides times liters so I can get that's just a little bit more right. So you see how we have liters, we have so we can multiply that with moles. Yes. Oh. 0. Yeah. Capital is more.
Once you finish the first part, try the second part.
Both sides are all times liters. Moles to go in that. We have moles and moles.
Anybody done with the second part? First part and the second part? Yeah, keep working on that.
Okay. So molarity is equal to molar liters, but I write that out. So molarity is equal to moles divided by liters.
Okay, so it's actually two times to get
So it's not going to be dividing, so let's take this equation out. So can you write mole, moles, so we don't get confused by the capital M's and the L's and the M's. Okay, so what happens if you take liters times both sides?
one side gets canceled out. So it's just a few moles equals moles. Yeah.
Moles equals, go ahead and do it.
So you times by liters.
Times liters by both sides and then rewrite the equation. So yes. So those brackets.
Great question over here for the second part. Brackets like that mean molarity. Okay. Sorry, I think I may have mentioned it, I probably did not emphasize it. I will always ask for it in words, but if you put the brackets, that officially means molarity. Yes. Huh?
For the first part, you've got molarity, right? So your equation for molarity has moles divided by liters, right? And so right there. So it's not so right now, molarity is equal to moles divided by liters. Right, MO that one times. And that's equals molarity capital M. Multiply both sides by liters.
I'm gonna start working this one just based on a lot of common questions. So there's a lot of confusion I'm seeing in terms of getting moles from molarity and liters. I've had that question asked a bunch of times, and thank you for asking that question. And so, whoops, gotta go back. Let me grab this and pull this over so it's in the notes. And so if you're having trouble with this, and a lot of people are, and that's okay, this stuff's abstract, and this stuff can be pretty abstract sometimes. So we've got molarity is equal to moles divided by liters, okay? And so we can rearrange this equation. I can take that times liters on both sides. Liters cancels with liters, and I can rewrite my equation as molarity is times liters is equal to moles. All right, and I'm going to use that to take my molarity right here of HCl and my liters of HCl, I'm going to turn it into moles. And once I've got moles, I'm on the moles to moles highway, right? Okay, so what we've got here is, so I've got 0.750 liters, right, times 2.0 molar. That's going to give me 1.5 moles, okay, of HCl. And now I'm going to write down, for this problem, I'm going to write down what it is because I'm about to get on the moles highway and go from HCl to zinc chloride. Okay, so if we go up here, so I'm going to start now with 1.5 moles of HCl. And now I need to go from moles to moles, so I need to use the ratios from my equation. So if I have 2 moles of HCl, I will make 1 mole of zinc chloride. Does that make sense? Anybody have a question on that? All right, so I'm pulling that right out of the equation. I'm going to put 2 moles of HCl is going to make 1 mole of zinc chloride. All right, now I'm going to go back up and I'm going to see, what did it ask me? Did it ask me, oh, it asked me for moles. So they're being nice. I don't have to figure out my molecular weight here, right? I have to use my molecular weight because they're asking for moles. So I never need to use the formula weight, the molecular mass to figure out the grams of zinc chloride there. So it's essentially 0.75. And we got down moles of zinc chloride, right? Okay, then a tricky thing here in terms of terminology. These brackets mean molarity. So in other words, it's not millimolar, it's not milligrams per liter, it's not parts per million. These are all units of concentration. Okay, it's not Elmo's per Sesame Street episode. It is molarity when it's that. Okay, and so now that's the first part of the question right there. We answered it. Then the second part is assuming the volume is 0.75 liters, so the volume didn't change. What's the molarity here? And it looks like it's going to be 1, right? But let's go ahead and solve it. So we have 0.75 liters and 0.75 moles. Molarity is equal to 0.75 moles of zinc chloride. And we are in a solution, once again, for this second part that says it's 0.75 liters. 0.75 liters of zinc chloride. And there can be other things in that solution as well. And that's going to be 1. 1.0 molar zinc chloride. Does that make sense? Okay, so now let's add that last little bit. It asks, what's the molarity of zinc or chloride ions? So that's weird. I've got this zinc chloride. Why? It's aqueous. Why is it asking for molarity of chloride ions? Back a couple weeks. If I have something that's aqueous and it's an ionic compound, meaning we have a metal and a non-metal, right? Zinc's a metal, chloride's a non-metal. What happens to it in solution? It dissolves. It breaks up into its ions, right? So if zinc chloride is aqueous, if I have zinc chloride and it's aqueous, that means that what it looks like in solution is a zinc ion plus 2, right? They don't stay together. They don't stay together like this when they're ions. 2Cl. Okay, are you guys used to my Cl's yet? Yes, no, or are they still confusing? Not like that, but I can do that better. 2Cl minus. Okay, both of these being aqueous. So now we can do this, right? So I actually have, so the best way to do this would be, we'd go back onto the moles highway again, right? I've got a molar, I've got a volume, I could get moles, I could go from moles of zinc chloride to moles of chloride, right? But can you see what the answer is going to be just looking at it? If I have 1 molar zinc chloride, what's my molarity of chloride ions going to be? I can go onto the moles highway for this. Okay, you guys aren't jumping out on that. It's not obvious, so let's go ahead and do the moles highway. Those of you who think you have a prediction, but we're too shy to talk about it, see if your prediction is correct. All right, so what I've got to do is I've got 1 molar, right? It's 1 molar, and it's also 0.750 liters. Of zinc chloride. All right, so this then becomes a volume of zinc chloride to moles of zinc chloride to moles of chloride to, we're going to go concentration, right? So concentration, oh, that's a new one, of zinc or subchloride ions. Which is okay because our volume isn't going to change. All right, so I know I have 0.750 liters of zinc chloride. All right, I know my molarity of zinc chloride is 1 molar. We just solved for that right there. So what that says, if I have 1 liter of zinc chloride, I'm going to get 1 mole of zinc chloride. From my balanced equation right here, 1 mole of zinc chloride makes how many moles of chloride ions? 2, right, okay? 2 moles of chloride ions. Okay, let's go back. Liters cancels with liters, moles cancels with moles. We're now at moles of chloride ions. And now what I need to do is I have moles of chloride ions. I need to turn it into a concentration, right? Here's a trick. I've got moles on the top, so if I divide by liters on the bottom, I'll have molarity, right? So I could spit out my moles and put it in my molarity equation, or I could just divide by liters. My liters hasn't changed. Nothing's happened here to add liquid. It doesn't say that liters have changed. So we know why liters haven't changed. So if I like 0.75 or 7.5 liters of, that's going to be chloride ions. They're in the same solution, right? It is the same thing, actually. And so 2 divided by 0.75 is going, 0.075 is going to be something greater than 2. Well, it should just be 2. What was that? Oh, I got the 0.75s cancel.
Yeah.
Yes, okay, thank you. Right? So if I multiply across the top and I divide by the bottom, I've got a bunch of ones. I've got a 0.75 on the top and a 0.75 on the bottom. And I end up with 2.0 molar chloride ions, and all is right with the world. Is that what people, those of you that had it in your head to begin with, is that what you predicted? I don't know that anybody had it in their head based on the lack of nods. So that's how you would solve it. Okay, by going through and solving it rather than doing it in your head. And solving it is just fine. Questions on that problem? Questions on parts of that problem? Okay, having worked this with you today, I'm really glad we have this extra review today. Having worked this with you, a lot of people need to actually go back to moles and liters. Maybe I'll put that on the homework. But moles and liters and how getting moles from liters, manipulating that molarity equation, so that then you can go into this dimensional analysis and be able to work those sorts of problems for Squid Geometry. So I'll put some of those in the homework. If you're having problems with them, I want you to make sure to practice them as well. All right, it's going to be a big part of the test. This is really going to be super important. All right. I'm available 1 to 5 today. If you want to stop by, come let me know. And if you forget to let me know, you can always email me and let me know you're going to come by. I expect to be here till about 5 anyway.
Can I see you today?
Yes, absolutely.